Hi everyone. So we just learned about how to graph quadratic equations, and now we're going to talk about how to potentially solve quadratic equations. And we're going to we could solve them graphically, but I'm going to show you how to solve them several different ways algebraically. So the first way we're going to talk about is solving with square roots. This tends to be one of the easiest ways, particularly if your equation is set up right for it. So when we solve with square roots, basically what we want to do is get the x squared by itself on one side, and then we can square root both sides. So let's just start with our examples. The first example is x squared is equal to 81. So if you remember what I literally just said, I want to get the x squared by itself on one side. Good news, the x squared is already by itself on one side in this case. So now that I've got the x squared by itself, I don't actually want x squared, I just want it to be x. So I need to get rid of the squared part. To get rid of the squared part, I have to square root both sides. So I'm going to square root x squared, and I'm going to square root 81. But the thing that I want you to really make sure that you remember on these ones is that when you square root a number, it has to be plus or minus. So anytime you have to write that square root sign in front of a number, you want to put the plus or minus sign on there as well. The reason why this is because, actually I'm going to show you in a second. So from there, the square root and the squared on the right side cancel each other out. Like the square root and the squared, they're opposites of each other, which means that they cancel each other out. And so now I'm just left with x. And then on the right side, I have plus or minus the square root of 81. Now, if I were to plug that into a calculator, the square root of 81 is 9. So that means I have plus or minus 9, which means that I have two solutions. It's x is equal to positive 9 or x is equal to negative 9. So let me show you what I mean when I have to have that plus or minus really fast. So I get these two solutions. The x could be 9 or x could be negative 9. The reason why it could potentially be both of those is because when I square something, it's always positive. Squaring anything will always be positive. So if I go back to my original equation, which is x squared is equal to 81, excuse me, I could potentially plug in a positive 9 for x, right? And I could say 9 squared is equal to 81, and that is true because we know 9 squared is 81. But I could also put negative 9 squared is equal to 81 because what this equation is telling us is we're going to do negative 9 times negative 9. And we know that a negative times a negative is a positive. And so negative 9 times negative 9 is a positive 81. So both of those answers are totally true. That's why we need to put that plus minus in front of anything that we take square roots on. So those are my two answers for the first example. Now let's look at the second example. And the second example is 10x squared is equal to 100. So the first step is to get the x squared by itself. To get the x squared by itself, we need to get rid of this 10. Right now the 10 is multiplying the x squared. So to get rid of it, we're going to divide each side by 10. And when we divide the left side by 10, we're just left with x squared. Great. And when we divide the right side by 10, we end up with 10 because 100 divided by 10 is 10. Now we have the x squared by itself. So once we get the x squared by itself, we're going to square root both sides. But remember, anytime I square root a number, I always have to put plus or minus. You don't have to put the plus or minus in front of the x, mostly because it's kind of the plus minus is being taken care of when we square root the number. You could potentially do that, but it's going to give you the same answers. So the square root and the square cancel each other out on the left side. We're just left with x over here, and then we have plus minus the square root of 10. Now the square root of 10 cannot be simplified. You could potentially plug it into a calculator and get a decimal version, but for this case, for these questions, I want you to try and keep them in simplified radical form. If you can't remember how to do that, then you can plug it into a calculator and get the decimal version. That's fine. Okay, but remember, so this would be x is equal to the positive square root of 10 and x is equal to the negative square root of 10. It's really important. We've kind of talked about this in the last lesson on imaginary numbers. It's important that you make sure that the negative stays on the outside of the square root. You don't put it on the inside because that would make it an imaginary number, which in this case it's not. Okay. Let's look at the third example. So the third example is 3x squared minus 5 is equal to negative 23. first step is to get the x squared by itself. So we need to move the 3 and the 5. I'm going to start by moving the 5, and I'm going to add the 5 because right now it's subtracting. So that cancels the 5 out on the left side. We're left with 3x squared over here. And then negative 23 plus 5 gives me a negative 18. Okay, now to get rid of the 3, I'm going to divide each side by 3. We're left with, the 3's cancel out, and I'm just left with x squared is equal to negative 18 divided by negative 3 gives me a negative 6. And then now that I have the x squared by itself, I can square root both sides. So I'm going to do the square root of x squared is equal to plus or minus the square root of negative 6. Now we just talked about this, but when we have a negative inside the parentheses, that means it's an imaginary number, right? So on the left side, the square root and the square cancel out. We're just left with x. That's great. But on the right side, I don't like that there's a negative on the inside of the parentheses or on the inside of the square root. So I'm going to pull that out as an I, which means I can simplify it as plus minus I square root 6. And that is your answer because square root 6 can't be simplified. So we're kind of done there. We can write it out as two separate ones where x is equal to I square root 6 and x is equal to negative I square root 6, but both of those are my answer. And they're imaginary because we can't square root negative numbers. So some of these questions on your self-check might be imaginary. All right, and then for the last example, we have 8x squared plus 6 is equal to 30. So I'm going to start by getting the x squared by itself. I'm going to move the 6 first by subtracting it. When I subtract the 6, I'm going to be left with just 8x squared on the left side. And then on the right side, I'm going to be left with 24. Then we're going to divide each side by 8 to get rid of the 8 on the left side. The 8's cancel out over here. We're left with just x squared is equal to 24 divided by 8 gives me 3. And now that I have the x squared by itself, I'm going to square root each side. So I get the square root of x squared is equal to plus or minus the square root of 3. The square and the square root cancel each other out. I'm just left with x is equal to plus minus the square root of 3 because the square root of 3 cannot be simplified. Once again, if you are nervous about the whole square root thing, you could get the decimal answer, but try to remember how to simplify radicals if you can. So my two answers would be that x is equal to the square root of 3, the positive square root of 3, and then x is equal to the negative square root of 3. And notice that all of these answers all of these questions had two answers. That is going to ring true for all of the rest of the examples and videos that we have. So everything will have two solutions, unless it's a special case. But that's one really important thing to kind of remember and notice, that you want to make sure that for this particular lesson, you have the majority of your answers have two solutions. And this is how we solve quadratics with square roots.